Thank you, Bastien. Good afternoon, good evening, everyone. So I'm Andrew Ogilvie. I'm a researcher in hydrology at IRD, which is the French Research Institute for Sustainable Development in the GEO research group. And I'm currently the FIGCC chair, i.e. the FRIEND coordinator. So I'm going to present some of the FRIEND Water program and some of the activities in the last year. So FRIEND is one of the UNESCO IHP flagship initiatives. So IHP is the Intergovernmental Hydrological Program. It's essentially the UNESCO water family. And so within it, there's about 170 the national committees and the focal points. There's flagship initiatives. So we're going to present three today. There's other ones like Large Rivers, GWADE that you might have heard of. And then there's 29 UNESCO water-related centers, like IHE Delft or like the ICIREWARD in Montpellier, where I'm also based, and then the UNESCO water-related chairs. So FRIEND is the oldest IHP flagship initiative. It was created in 1985, and initially it stood for Flow Regimes from International Experimental and Network Data, and it's evolved a bit over time to become a collaborative network on regional hydrology and international data exchange more widely. So we, under HP9, FRIEND reformulated its strategy and its objectives. So there are four main pillars. The first one relates to data, relates to data sharing. So data collection and sharing, and so that involves activities like data rescue, but also data collections and experimental basins, but also other activities using Earth observation or citizen science, and trying to disseminate that information through open access platforms, for instance, IHP Winds. The second pillar is related to the impacts of global change on hydrological regimes and extremes. So it's concerned with a lot of modeling, specifically on floods and droughts, and then quite a lot of support as well to early warning systems or disaster risk reduction strategies. The third pillar is water society interactions and equitable water management. And so it's more interdisciplinary, looking also at issues like sociohydrology and transboundary water governance. And then the fourth pillar is the educational component, both educational resources, but also support to more operational partners. The FRIEND is organized in regional groups. So at one point there was up to 9 regional groups, and these have been restructured to consolidate the groups and increase their visibility and regional collaboration. So notably the Hindu Kush, which had less activity recently, needs to be revamped and integrated in some of the Asian activities. And the Congo basin was integrated in the Africa and the Western Central Africa group. And the Nile Basin is currently trying to be revitalized. There's been some meetings last year to try and redevelop some of the activities in the Nile Basin. And the gray areas you see on the map are countries where we don't have necessarily active partners. So we're always looking to broaden the network. FRIEND has also renewed its governance under HP9. So the main change is that we now have the support of the Secretariat, which is the UNESCO Category 2 Center ICIREWARD. We also changed, renewed the coordinators. So obviously, Bastien for Europe. We have Oula Amrouni for the Mediterranean, based in Tunisia. We have Santiago Yepes for Amigo Friend in Latin America, who's based in Chile. We have Jane Tanner, who's from South Africa, coordinating the South and East Africa. We have Ernest Amoussou from Benin, coordinating Western Central Africa. And then we have Quinn from Vietnam, coordinating the Asian Pacific. We also have some deputy coordinators. So for instance, Stéphane Dietrich for Europe, and we also have Augustina for South and East Africa. And then we have some thematic coordinators like Adeyemi, Olusula, and David Guapetsa, on essentially on transboundary water governance and water management. So just briefly, ICIREWARD, if you haven't all heard of it, it opened in 2020. It's a Category 2 UNESCO center. It stands for the International Center for Interdisciplinary Research on Water System Dynamics, and it gathers disciplines from human sciences to well, hydrological sciences and earth sciences, with 17 research laboratories, 13 institutions, and over 450 scientists. Just an overview of some of the activities, maybe in the friend groups. So many of you probably know the Eurofriend. There's activities like the Robin database to try and share streamflow data um, across the countries, and we're especially amongst researchers. There's also research on machine learning and compound risks, and obviously the regular webinars. Um, in Asia Pacific, there's other issues also being studied, so a bit, well, Friend, as I say, has evolved into other aspects as well. So we're also looking at some issues relating to water quality and emerging pollutants, which may have some links with what we might hear later. Um, in South and East Africa, there's also research again on machine learning and AI recently, or Internet of Things, water monitoring systems. In West and Central Africa, there's quite a lot of work focusing on data centralization, so the data sharing and data rescue activities. And there's also activities on flood warning systems and eco-hydrological observatories. In Latin America, there's quite a lot of work also on sediment aspects, and then some research more generally on large rivers, and also some webinars. And then on MedFriend, there's various activities, but also some which touch on eco-hydrology, and with the development of observatories and many trainings and conferences. Otherwise, in the last few years, we've tried to increase a bit the visibility and the networking of Friend. So we have a new website, the LinkedIn page, which we try and use more and more. Events like obviously the Eurofriend webinar, which has a lot of visibility. So that's also why we try and expand it to other groups of the other regional groups who are in Friend. So we've had some webinars like that. Then punctual events in the different regions, and then the conferences. I'll come back on that. And then obviously participation also at EGU. Bastien is often active at EGU, Adeyemi often at AGU, and several of us at IHS sessions. So for the global conference, we organize it every 4 years. It's organized with IHS amongst other partners. The last one was in Senegal, and so one of the challenges is obviously getting people to these events. We had a good turnout from the region, from Mediterranean and West and Central Africa and Eurofriend. Um, just to highlight, there's only about 20% women, so I don't know how many women are in the room today, but certainly in some events we still need to do better to improve the gender balance in hydrological sciences, and also increase some of the travel grants to make sure that some of the young scientists can join these events. So the next one is in 2027, and we're having discussions with the Eurofriend group and with the South and East Africa group as to where the final hosting will take place. So we'll let you know hopefully soon. In parallel, its Friend is quite active in regional conferences, one of them being the Hydrology of African Rivers. So the last one was in Cotonou in 2021. And the next one is taking place in July. Some of you hopefully may be joining. It's in Morocco, in Rabat. And so you have the website and information. Most of these events we also try and add training events on the side to motivate people and to get the most out of such events. Publications, these conferences generally lead to what were previously the red books, the proceedings of IHS. And the last one from Dakar is being finalized. There's 21 papers being prepared. And overall, over the last IHP 8, there was 353 papers, somewhat related to the friend activities, and more than 1,000 other publications, including some of these communications and posters. Um, just a quick mention on collaboration with other initiatives. Indeed, it's something that's important within IHP, and within Friend. On data sharing, it's something that Friend has been involved in for a long time, working with WMO, working with GRDC or BAFG, working with the IHS Rehydrate group as well. There was a seminar organized last year as well between CH and Friend to try and promote data sharing in Africa, notably with the Robin Group. We're quite active on African hydrology, and we have indeed three friend groups in Africa, and so we work with initiatives like the ACNOW initiative and with the IHS Africa Regional Committee, and then with other HP9 initiatives. So eco-hydrology, as I mentioned earlier, World Large Rivers, and also HELP, who hopefully might join us in another of these events, and also with the IHP9 working groups. Just to finish, I just wanted to add a couple of slides related to why some of this data sharing is important. If we look at some of the media reports, so if we look at some of the publications, there's a strong lack of hydrometeorological data in Africa, but also in other areas. If we look in the center here, we have the radar facilities. We only have 37 currently in Africa, but we also don't have so many in South America. If we look at the left, at the data gap, we see that indeed Africa has got data issues, but obviously some countries in Latin America and Paraguay, or countries like in Asia, in Cambodia, where I'm now, also suffer from similar issues. And then we have the figure at the bottom where we see for the hydrological data, where also some of these databases, they peaked in the 1980s, but there's been a decline, especially in Africa. So sometimes we have a low network density, and sometimes it's still declining. And then we have maintenance issues because there's not necessarily the right funds to train the staff, to get the staff into the field. And then, so that means the data that we get is not always reliable, so there's a lot of work that needs done on that. And then sometimes the data is sold, introducing also cost barriers. So Friend has activities, as I mentioned, on educational and training. So we organized workshops like on data rescuing with scanning archives with some tools like Nuno, trying to retrain some of the national staff also on hydrometry aspects, both in the classroom and in the field, and then all the data management aspects related to databases and analysis. And then we also obviously have a more research component where we try and support some of these observatories in hydrometry and the academic collaborations with institutes across the world to try and support young researchers in analyzing this data and then supporting more operational aspects. So some of these conferences also try and support that. And then we also have some more direct modules or courses in some of these countries. And yeah, that's also why, as you know, in IHP9, we also try and promote IHP wins, and there's multiple platforms that exist, multiple data producers, and so we need to try and find ways to promote this data exchange through open access platforms. And I think I'll stop there for now.
Thank you, Bastien. Really, really nice to be here today, and to share some insights on the International Sediment Initiative. So my name is Will Blake. I'm a professor of river basin science at the University of Plymouth in the UK, and also director of our Sustainable Earth Institute, which has an interdisciplinary remit to help research align with SDG priorities. And I'm also the co-lead of the erosion and sediment transport theme within river basins within the UNESCO International Sediment Initiative. So I joined the ISI in 2004. So ISI had a refresh with the advent of Phase 9, and so the advisory board was renewed across the piece, and ISI took a new look at its remit, in particular with alignment to the Phase 9 priorities. So I'm going to talk. I'm fairly new to the ISI, and I am much more tuned into the theme that I lead. So I want to talk a little bit about the ISI broadly and the broad remit, and then I'll take a look at the theme that I'm involved in, and give some examples of how we see it developing and how people can get involved. So it's established in 2002. So the original scientific advisory team stems back to that time, and then as I said, was refreshed in 2024. Um, but the initiative, as you can tell from the title, is about sediment, but very much about the broader sediment challenge within river basins, thinking holistically from erosion on hill slopes through to sediment transport and deposition from catchment to coast. So thinking about all the different challenges with sediment management along that soil sediment continuum. And then particularly thinking about how scientific evidence can be brought to bear to bring positive change in terms of management. So very much about linking science into policy and management needs, as you'd expect. Um, so this is the current advisory board. The first meeting we had of the advisory board 2024, and we have our second one will be taking place later in this month. So it's quite a new, in terms of its rebirth, it's in a fairly new phase. These are the strategic objectives, supporting broadly the global agenda for sustainable and integrated management of land and water to provide sound soil and sediment management. I put the soil in the brackets because in my world, of course, that's where a lot of the sediment originates. Think about linking science into policy and management needs from local to global scales, and transboundary settings, of course, interconnected with IHP agendas. A really strong agenda in terms of improved understanding of sediment challenges. As with many river basin processes, sediment dynamics can be extremely complicated in terms of sort of transport mobilization and so on. So really understanding how that works in our scientific world, but communicating that across is incredibly important so that we can strengthen capacity for sediment management, promoting education training and cooperation, and then of sort of a broader communication in terms of understanding the nature of sediment challenges to ensure policymakers are well tuned in. I think particularly for us in thinking about interdisciplinarity of river basin management challenges more generally, and with sediment, a lot of the challenges we face are based around infrastructure and sort of engineering aspects of that disrupt the soil sediment continuum. And that can be ensuring there's a truly interdisciplinary understanding of sediment problems for major infrastructure programs is a really important agenda. And we're finding that policymakers and sort of major donors are increasingly asking questions about the integrity of environmental plans around infrastructure development, and that's something we're really putting attention into as we'll come on to. This is the governance structure. I think there's some commonality with what we heard from Andrew about the FRIEND program. So of course it's driven by the IHP Secretariat. So we have colleagues in Paris who supervise the activities. But the ISI Global Secretariat itself is based in China. So colleagues in the International Research and Training Center on Erosion and Sedimentation in China provides the leadership of the program overall. And then I'm part of the scientific advisory board that you can see below, which then provides the scientific steer to activities within ISI. So there are two component parts to the advisory board structure. We have regional groups that have regional leads, as you can see on the left, and then we have our thematic areas, which then have coordinators as well. So I work within the erosion and sediment transport component. We have colleagues working on sediment-related hazards, particularly landsliding, and then new in this new rebirth of the ISI board is glacial sediment, particularly glacial outburst floods were brought into the remit. And so those three distinct themes have two scientific leads on each, and then there's a lead for each of the regions, and that's the group that comprises the advisory board. And then just sliding that around out of my way on my screen. You can see then below there, of course, is the wider UNESCO water family network. And I think something that we're really keen on doing with the sort of the reboot of the ISI is to reach out into the UNESCO water family too. And I think I was quite inspired by what we heard earlier about the Friend Network. It's really established. There's a lot of buy-in from the wider water community, and I think that's something that ISI now is moving toward as well. It's as we see in the activities later on, we're thinking a lot about influencing policy and ensuring sediment is on the map when it comes to big river basin decisions. But we need to reach into the scientific community to ensure that we're gathering as much intelligence as we can from the good research being done. So one of the key things that's taking place within the regional working groups is the development, sorry, in the regional with the regional leads is development of regional working groups and trying not to necessarily reinvent something new that exists, but looking at where there's good work being done on sediment within the global community and ensuring that there's good interconnection with ISI activities so that we can benefit from the impact of research being done. And just as one example, then in the European side, because I cross over into the European group as well with colleagues. For example, the SEDNet group within Europe is a very strong community working on sediment-related issues, and so ISI seeks to build relationships with SEDNet as an existing group rather than reinventing new groups, so we can capitalize on what's happening already and bring extra value and impact pathways through what we're doing. So yeah, that's the governance structure. In terms of current activities, on the sort of the dissemination and policy engagement side, we heard already from Andrew about the wind system. It's high up on our agenda in ISI to start to make use of this. We're really conscious that there's a huge amount of evidence out there in terms of sediment data sets. There's a lot of sediment-related scientific outputs, but they're very inaccessible to policymakers. So what we're looking at doing in this next phase is really adopting the WINS approach, and other technologies to I guess to integrate and fuse the understanding we have from the widespread literature, and to use that to distill out policy briefs on concepts and management challenges, so that some of the sediment challenges are better understood by decision makers within government. Then to think about explainer documents, technical briefs, and guidelines on the tools that are available to support building evidence bases to support management decisions. And then the third set of outputs that we're building are demonstration case studies where best practice in terms of sediment management can be exemplified and shared, so that we can be mutual learning across river basins in terms of managing sediment challenges. So it's very much about synthesizing what's out there in terms of knowledge, putting it through lenses that suit the questions being asked by the policymakers, providing documentation and training to support policy and practice action on the ground. So I think thinking about what we've heard from Friend, I guess the ISI is less about doing the research, it's more about harvesting what's out there with the budgets that we have available and creating opportunity for that information to have a stronger impact pathway. And so I think it's as a board, we're really interested in, and I guess we're finished there, but thinking about those regional groups and thinking about scientists out there who want to find new impact pathways for their sediment related research. We're really keen to hear and to bring that into these guidelines and briefs that we're producing, so that we can maximize the science that's being done in the sediment related world. So what I thought I'd do is that's the ISI broadly. What I was hoping to do was just to give a little bit of insight into some of the theme, the erosion sediment transport theme, just to sort of highlight some of the concepts and challenges that we feel are the priority at the moment in terms of conceptualizing sediment research and application. An overview of the tools for management where we're building current guidelines, and then a quick demonstration case study, if I have time, just to give an example of the kind of stories and narratives that we want to be hearing from other parts of the community to bring to policymakers. So, Bastien, do please put your hand up if I get towards my time before yeah, the time runs out before I finish. Just give me a shout. Um, so the policy brief we're working on at the moment is very much about raising awareness in policymakers of the complexity of sediment management challenges, and so this is framed very much around the role or the position of erosion and sediment problems within the food, water, energy security nexus, but also thinking about environmental security. And the challenge here, as I'm sure many people are aware, is that on the one hand, you might be fixing a problem in terms of challenges, pollution, soil erosion, pollution of waterways and sediment, siltation of dams is a really critical problem that we need to challenge. We need to keep the soil where it should be in terms of sediment production. We want to stop dams from silting so that they can provide power, and we need clean water supplies, of course. But one of the challenges with infrastructure, as well as being challenged by too much sediment coming from the hill slopes, is that infrastructure can hold back natural flows of sediment, which are really important for biodiversity and for geomorphic stability of the coastal zone. So we kind of have a bit of a paradox in terms of too much sediment in some contexts and not enough in others. And one of the key factors at play in both of those narratives is infrastructure within river basins. So really understanding the complexity of sediment flows and processes is an important part of our mission. And it's certainly, as we know in many management contexts, it's not one size fits all. So that's a sort of a broad one of the broad sort of areas where we're trying to really distill down that complex understanding of river basin systems, sediment systems, for policymaker understanding. And then the other big challenge, as in other aspects of river basin management, is then trying to sort of close that gap between the top-down global requirements, needs, policy drivers, and then the bottom-up reality of delivering change. And that's something we're really looking carefully at in terms of interdisciplinary working across social sciences and between natural sciences and social scientists, participatory action, design thinking, to try and bridge this gap, this implementation gap, which we see in many areas of environmental management. But it's incredibly important, of course, within the sediment context. So broad, very high level overview of concepts and challenges that we're working with in terms of tools for management within the river basin area. We're starting to develop guidelines and reaching out to experts globally to build guidelines on the tools that build the evidence bases that can support decision making, both top down and bottom up. So thinking about in situ sediment monitoring, tracer-based tools, sediment budget frameworks, process-based models, geospatial models, and remote sensing tools. So we're building a suite of explainer technical documents on these different tools and approaches for building evidence bases. Yeah, I won't go into too much detail on these, but it's just worth just flagging a little bit about, for those who aren't familiar with these methodologies. So in situ sediment monitoring using sensor technologies and tools to build databases, then how do we integrate those databases across regions and globally to learn from each other? So the secretariats in China is looking carefully at sediment evidence databases and how can we sort of create some kind of a stewardship system for sediment databases that can be used for learning and also used for underpinning modeling develops and so on. Tracer-based tools. I work closely with the International Atomic Energy Agency on nuclear and isotopic techniques and other tools for understanding forensically a little bit more about what's happening within river basins. So using analytical techniques to understand the sources of sediments and sedimentation rates and so on. Again, building evidence bases of problematic processes within river basins to support management decisions. Sediment budget frameworks. This diagram hopefully illustrates where we're coming from here, but it's combining, fusing tracer data, monitoring data, survey data to understand much better and pictorially understand where the sediment's coming from, where it's going to, where it's ending up, where the problems are, and again using that as a support mechanism, for example, for infrastructure projects. Thinking about the modelling side, this is not my area of expertise, but colleagues within ISI work carefully on thinking about the modeling expertise and trying to tune models to the questions that need to be asked in terms of sediment management, and thinking about how we can use those to identify hotspots and hot moments of sediment transport, which can then be used to deploy um, management, often quite limited management resources on the ground. And then finally, remote sensing, example here, where we're using NDTI to think about how different tributary parts of river basins, this is flowing to a dam construction site, understanding the seasonal dynamics of sediment flows. So again, resources can be deployed on the ground to try and help manage some of those sediment problems at source. And this is one example where we're working at a catchment scale. There's been work done globally as well, looking at how sediment data, turbidity data can be used to understand globally the challenges of sediment flux and different geographical um, dynamics therein. So a whistle stop tour of these are the kind of tools within our theme that we're building up technical guidelines on, and we welcome input from the wider community. And just one quick insight into a case study, if I have time, Bastian. I'll do a quick walk through. Just this is an example of a study that I worked on in terms of understanding the complexity of sediment dynamics, but I like to share it because it's one where we work closely with social scientists and design thinkers to really embed community thinking and community knowledge in the development of solutions to the problem that you can see laid out here. This is in a lake basin in northern Tanzania, where you can see the challenges of soil erosion and sort of water quality issues and then downstream siltation. Um, in this particular case, working closely and really driven by our colleagues at the Nelson Mandela African Institution of Science and Technology, it was about trying to understand the problem holistically, understanding the drivers of some of the problematic behaviors, the fact that it's climate change, changes in rainfall patterns, land tenure, conservation are driving some of the problematic behaviors which themselves, in terms of grazing, are a symptom of bigger challenges, and understanding the consequence in terms of erosion and sediment problems downstream. So fusing both disciplinary knowledges, but also local knowledge from the community, fused with scientific knowledge from what we were doing. And the idea was, and this is more for illustration, I don't have time to go into the detail, but we were able to use the sedimentary archives within the river basin to really understand the complex temporal dynamics of change within the landscape. And we could relate the geochemical story of the sedimentary record with remote sensing evidence of increased gulling with the landscape, increased erosion, and the changes in sedimentation in the lake, and that could be related to oral histories. And so it's about fusing together different knowledge systems from the sediment. Martin Winans, a colleague of mine, PhD student, did some forensic work using tracer tools and modeling to determine which of the tributaries were contributing the most to the larger lake, and then did some work unraveling the relative impact of land use change and rainfall patterns to understand those drivers. And it translates, as we can probably imagine, that land use change is one factor, but really compounded by changes in rainfall patterns. So we're getting quite a dramatic spiraling out of control in terms of erosion processes because of that combination of drought and land management change. So that sort of double impact of land use change and climate change. So just to sort of put that into context, I think the aspect of this that I enjoy sharing with people and with policymakers is that it was the development of evidence with the communities and the fusing of knowledge gave a lot of ownership in terms of the evidence and the needs. And so in these particular case study areas, there was a lot of bottom up activity to try and remediate the problem. And so there's a lot of change happened on the ground as a result of building evidence bases together. But I think the challenge we have, and this is where I guess as a multilateral entities and multilateral programs we have, is that how do we then scale out from those examples, often research-led examples that are quite regionally specific or locally specific? How do we then scale up from that? And I think that's one of the things ISI really wants to do. It wants to learn from the community where things have gone well and be able to take that information, process it, and communicate it to the policymakers and to the donors, who can then lead and push or drive change on the ground by helping us deliver programs at scale that can bring change in terms of sustainable sediment management. So I think I'll leave it there. I guess the call out is that if from different regions people are interested in being involved, then please do get in touch, and then the regional coordinators can ensure that you're engaged with the regional working groups.
Hello everyone, my name is Leila Hashwa. I'm stepping in for our director, Stefan Dietrich, which I think most of you know over here, and we're just gonna give a bit of introduction about the UNESCO IHP International Initiative. Sorry, it's moving by itself. Yeah. I'll try to answer the questions. If there's anything that I cannot answer, please feel free to reach out to Stefan later on or anyone who's mentioned over here. So we'll start by talking a bit about what is the current status of the in situ water quality monitoring and reporting. So first of all, as you know, there's in the UN Sustainable Development Goals called number 6, which has different parts. We're focusing about 3 of them, the 3 indicators, which is 6.32, 6.31, and 6.61. And from the different years, if you can see, I mean, from the last report, we know that from 2024, 56% of the monitored water bodies showed good ambient water qualities. If we look at 2022, an estimated 113 billion meter cube of house water, wastewater was discharged actually without safe treatment. And around 50% of the reporting countries had water related ecosystem types in a state of degradation, which means that, as you can see, there are lots of negative things. And if you look over here at the Sustainable Development Goals as well, so focusing more about the 6.32, you see that we had an improvement in how much of those samples we have. So in 2017, only 71 countries reported on that. 2020, it increased to 98, and in 2023, it increased to 121 countries. This data is taken as well from GEMS data, which is the water quality run by our center. And so what does that actually mean to us if we look at it by division of the number of water bodies and in the different quartiles of who's richest, basically the GDP per capita? So you can see over here that around 20 countries, which are basically the ones which have the lowest GDP, reported only about 3.5%, which means of the water bodies. And this literally means for us that there's a lot of gaps within the in situ water quality data, probably arising from operational monitoring, and the hotspots in those countries are mainly, as you can see in this picture over here, you can see it's mainly in the Africa region, a bit in the Asia. And you can see it as well over here. There was recently as well the State of the Global Water Resource Report, which was published by the WMO over here. And you can have a better look at it if you want. So that's just updates from the different things. As well, in relation to GEMS, we as well report, as you know, in the UNEP, the Global Water Quality Database. You can see here, you can see as well, similarly, that over here we have a lot of stations, and here as well a lot of stations, but then again, there's a lot of lack of stations in Africa and again in Asia. That means that there's a need for improving the water quality in the UNESCO IHP implementation plan. And so how can we achieve that? Before we reach that, I just want to mention a couple of things that have been achieved actually in the recent years. So in the UNESCO IHP, there was the basin level water quality assessment, which took place in Mongolia for the Kara River and Senenge River. You can see over here, if you scan the code, you can read more about it. There's been lots of open access publications on emerging pollutants in the wastewater reuse. And here is this one of the book itself, which was in Springer. So this is the thing that has recently been discussed, which is the theory of change, which is starting from this year till 2029. And here I would like to focus a bit more about the different things that are expected and how we can reach them. So let's focus just on where the outputs is. So we're expecting 4 different outputs. First of all, of the water quality management institutions to be empowered to use remote sensing or monitoring quality in inland freshwaters. And that would be what we would be asking for. How can we get people more involved in this initiative so that they can do this thing? So similar, before I go to another point, this obviously each one of them we're trying to link to the IHP. And so the different activities that would be done in order to achieve that would be that we include local and global water quality portals. We have more capacity development workshops and courses, and we develop a unified approach for the satellite monitoring of inland water quality with partners. The outcome would be basically that the member states have increased their capacity to monitor, analyze, and report on their water quality. Let's look at output 2. The member states can efficiently plan and implement the water quality monitoring program, including the data collection and the analysis. Again, we're linking it to different outputs, but basically the activities would be to create an optimal sampling framework, creation of citizen science, which is a very important thing now. So basically the first one was what we just talked about, the remote sensing. The second one is the citizen science for data quality guidelines, data sharing and reporting, which is as well what our institution does a lot, and support for water management plans. Number 3 is the enhanced capacity institutions to understand, predict water quality effects and emerging pollutants in hydrological extremes, as there will be lots of challenges coming up with the weather. So the activities would be researching networks on emerging pollutants, scientific activities and publication, and establishment of partnerships between research and operational entities. And the first one would be amplified outreach and visibility on the importance of water quality and its relation to the UN and the SDGs. This would as well mean that the activities would be Water Quality Citizen Science Week, educational outreach to the UNESCO, webpage created, and contribution to international water events. So all of those things will lead hopefully to outcomes of the member states having increased their capacity to monitor, analyze, and report on their water quality. The member states have increased their capacity to identify and address emergent water quality challenges, and that they have increased their capacity to manage their water quality. This will have lots of impact. The most important one, which we all agree upon, is that the member states have filled the global water quality data and knowledge gaps and are empowered to accelerate their progress towards achieving the SDG 6, accounting for novel and emerging pollutants. And this will involve as well, I think Stefan here wanted to say that this will involve as well the technical secretariats and the UNESCO secretariats and advisory committee members. And so just to touch a tiny bit about the UNESCO Citizen for Water, you can see over here, this is a platform which was as well created, and the activities under the UNESCO Intergovernmental Hydrology Program, UNESCO IHP. It's a collaboration workspace on the UNESCO Water Informative Network, as well the IHP wins. And here you can just, if you would like to go and try to check the different things, but it's in progress at this point. Before the last slide, we talked a bit about remote sensing and Earth observations. The important thing is that the Earth observations will be more in operational water quality monitoring. So obviously this has lots of opportunities and challenges. Those are some of them. So extensive spatial coverage at high temporal resolutions. It will facilitate monitoring of remote areas. However, there's coarse spatial resolution restricted to optical parameters. And you can obviously read more about them over here. And the UNESCO IHP will aim to mobilize those scientific communities together, whether through the AGU, EGU, or GPGU. So this was as well announced in the EGU. We had a presentation in this regards. We had the first meeting. And then again, there was a poster about it. So what we are asking, what we need from you is that if you could join the IIWQ, so try to be part of this network of researchers and operational hydrologists. Try to integrate research outputs into large-scale water quality reporting. Adapt novel methodologies for water quality monitoring to be integrated into operational monitoring and practicing research under the UNESCO. So here we're asking as well for the Eurofriend and IIWQ. There will be hopefully a workshop, which would be between the Friends Water IIWQ and the WMO. It will be aiming to bridge the gap between the research and operational hydrology and will be taking place in Koblenz next year in June. So the summary is that there's lots of substantial gaps for in situ in situ water quality from operational monitoring with hotspots, as said before, in both Africa and Asia. And we should try to consider the citizen science as a measurement in addition to the Earth observation data, because both of them are available and can actually help in filling those gaps which arise. So research data and knowledge are needed to be integrated as well into the operational hydrology in appropriate ways. And a mature research community for water quality is available, but we can always improve things. So the UNESCO IIWQ is a collaborative platform, and we would really, again, ask you to join it and to further promote the approach in improving the science, practice, and policy interface. Yeah, so thank you.